HVAC 360 is brought to you today by Lefty's Construction Mart, where this week we have some back to trade school savings for our future workforce. First up is our big book of rule of thumbs. This is a no-brainer for newbies that helps keep your answers in the ballpark even if you can't find your seat. Next is the Trap Keeper Jr. This is not to be confused with the legendary Trapper Keeper from the 80s. This simple muzzle-like device allows youngsters the chance to listen twice as much as they speak. And there's a special bonus setting for a questions-only mode. Also available for those more experienced job site blabbermouths is the Trap Keeper Senior. Stop on by to get these items today before they're all sold out at Lefty's Construction Mart. Hey, welcome back. Matt Nelson here, your host for HVAC 360, helping you be the best and the brightest in the field of HVAC. Each week, I'm either sharing information and lessons learned from the field or talking with industry experts. This week's topic comes from an article that I saw in High Performing Buildings magazine titled Green Roofs, Blue Roofs. You know, I've experienced a lot of green roofs before, but I had never heard the phrase blue roof. So I wanted to dig into that a little bit more. It's been a while since I've designed anything, but I'm like, did I miss a new trend in plumbing design? So let me tell you a little bit what I found. So in regards to the article, these type of roofs, we're going to focus mostly on flat roofs. They might be low sloped, but in general, we're talking about flat roofs that we can be able to mount these green roofs on or do something with a blue roof. And I'll explain exactly what is which in a second here. Just an added bonus is that this is really all about storm management or mitigation. And, it's when you do design, you have standardized rainfall rates in your local area or wherever you're designing your building. So you'll be able to take those and that on average, there might be rain incidents here and there. It's not the light rains. It's not the mild rains. It's the severe rains that you really want to focus on when you're talking about roof design. And that's really where these target. These are different types of solutions for those type of environments. One obviously is green, and it's more of a vegetative, and that's really what that green means. It's some sort of vegetative solution that's going to retain water. You're going to have soil. You're going to have green compounds and things like that. Green plants. And the other one is blue. When you talk about blue, you're talking more about detention or harvesting systems. Those are the two varieties. That's green versus blue. So why would somebody use a green roof? Now, green roof, some of the advantages are you can reduce the heat island effect. If you're not familiar with the heat island, what the heat island does is when you have a lot of buildings in an area, what they've determined is if they all have real dark roofs, you get an abnormal kind of microclimate around those areas. So you want to be able to kind of mitigate that intensity, that heat intensity that goes around. You want to be able to kind of reduce that. Again, that's something that the green roofs do really well. It provides habitat for some of the, whatever animals or insects, beneficial insects, I should say. You don't necessarily want the detrimental insects in there, but, like bees and birds and, things like that, they'll actually provide a habitat for those type of animals. And it really kind of boils down, a lot of it has to do, as far as pros, being some sort of aesthetic benefit to the building occupants, as well as, it's not, you can't forget the adjacent building occupants. So other people are looking down on somebody else's roof more than likely. And if it is a nice environment, it adds to their productivity. So even though they didn't necessarily pay for the view, it's better than looking at a bunch of fans and a cooling tower or chiller or what have you. Who wouldn't want to look on a roof like that? But, sometimes they just want green. All right. So we going over to the Blue Pros. So what are some of the advantages there? Water reuse is the big one. Whether you use it for reusing the water for toilets, urinals, or irrigation. That was a lot of what they talked about there. And is also compatible with solar arrays. Very, very important if that's something that you want to do in the future. You don't want to kind of eliminate. If you do that with a green roof, obviously the roof trays are going to be a little bit tough to maneuver around. So in the importance of stormwater management, I just kind of want to bring up this, and it really is at the source of all that we're doing here, is that cities and jurisdictions, sometimes they have a couple problems. They have a couple problems with the overflow, and again, that's with the peak storms that we're talking about. So what they do, and there's kind of two problems, and one is with just kind of generally speaking, the overflow of the storm, like their storm system can't literally handle all the water at one time, or you have situations in more antiquated systems where you're going to have a combined sewer and storm. If you're not familiar with that, that's basically in the old days. In different systems, they combine both the storm and the sewer together at a certain point. A lot of times they might be even coming out of buildings or houses separately, but when they get to the street, they've joined them into a single pipe. Obviously, the problem is that most people can, the sewage is one load in that system, and that's pretty, consistent day to day. There might be some, slugs, but it's just you're going to be able to handle that. And on average, you're going to be able to handle some mild to moderate rainfall, and that's not going to be an issue to the system. The problem with these combined sewer and storm systems is that when they get a large rain event, they have nothing they can do except let it overflow, and that's a problem because typically when I say overflow, you're like, Matt, where is this overflowing to? Well, unfortunately, it's any sort of river, any sort of body of water that's nearby. That's where they're going to have this overflow to, which is kind of gross, but that's the way the systems are designed. And they've tried to in some certain circumstances, they've tried to separate this out, the storm and sewage, and create a separate system for that. And that sort of alleviates a lot of that problem, but it still exists. So if you didn't know that happens, you can, like I said, you can have two pipes, one for storm, one for sanitary, coming out of a building, and they go into the same pipe, and you're like, what? It happens like that. So that's the combined storm and sewer. All right. So I guess one important point is, even if they're separated and they do have the overflow, that's still not going to be okay because they still do some sort of treatment on the stormwater side. They're able to kind of treat that and kind of look at that and analyze that before they let it go back into the environment. When they have the overflow events, you're picking up everything from road salt to different chemicals that you're spraying on, different plants, fertilizers, etc. Everything goes into the storm sewer, and then that overflows into the local waterway, and that can cause problems too. So it's just because they have a separate system doesn't mean that this isn't a really important thing to focus on. So what you find out is that that's some of the importance of storm water management. Now, when we talk about green roofs, people might say that there's a modest insulating effect, but it's really quick to point out that the insulation value that you get from something like that, you really could add, it really wouldn't cost you that much to add more insulation to a roof and, put a high albedo Now I'm trying to get that right because I've pronounced it albedo. Anyway, it's a white roof. So a lot of if you've been doing lead design at all, you're very familiar with the very white PVC looking roof that are out there. They're very slick and slippery, but that's one way to kind of reduce that heat idling effect. Because if it was darker, it would absorb more of the heat and would radiate, and that's something that they're trying to reduce and eliminate. However, I will throw this in there. Obviously, you need, depending on where you're at, you need to understand if a white roof is exactly what you want. If you're in a heating dominant climate, you may not get all the benefits from a white roof. You may have actual more benefits from a darker roof. So you need to account for that, or at least talk to your architects and figure out exactly what is the best type of roof for your environment. The other benefit, really, besides obviously insulation, we talked about that. It's really not that great. One of the main benefits is, again, this biophysical benefit. This, if you use it, if you're able to see the roof, if you're able to walk on the roof for a break time, or if you can see the roof from other buildings, there's going to be that productivity gain. And again, if that's that's really nothing to just disregard flippantly. You need to be able to take a look at that, because obviously, remember some of the productivity discussions we've had in previous episodes, that productivity, if you increase productivity a little bit, it just eliminates, it trumps and totally overtakes any sort of savings that you would get by removing that from removing the green roof from the project. Now, the blue roof, really, it's the simplest way is to use flow control on drains. Now, this is kind of where, when I was reading the article, it really piqued my interest, because I had never heard of flow control for roof drains. You just you took the area of the roof, you sized it for the rain event, and that's it. You put in a secondary storm drain that was larger, and you called it a day. So this is, it's so kind of prevalent, or is so simple, and it's been around a while. And that's where I got to talking to different engineers and different manufacturers reps. Because there's the basic systems, the stormwater management strategies. You have rain barrels, you have roof cisterns, you have the green roofs. You can I guess in some locations disconnect the downspouts. Other things are bioretention. We're talking about a vegetative filter strip, permeable pavement, enhanced grass swale, dry swale, perforated pipe systems, all these different types of stormwater management systems. But the simplest was this flow control drain. So I had to do some digging and investigation on what exactly this is all about. I will leave you that the rainwater harvesting, which I'm not really going to talk too much further, which is one of the benefits of using a green roof, and this is kind of more of a cistern kind of thing. The water that you can harvest on a yearly basis for some of these buildings. They really analyzed it, and it really was beneficial. If you're going to have, it significantly offsets the potable water demand for toilets, irrigation, urinals, things like that, that you don't need the potable water for. So it's something to definitely think about. So let me get, I talked to one of my engineering buddies, and I picked his brain about these blue roofs. And really what it boiled down to was he really didn't do a lot with the blue roofs. And that's, you have to think of the location. This came up again and again. It's very location-based. It's a very regional thing. And in the Cleveland area, northern Ohio, it's really not something that they see a lot of. So, a couple of things that he thought about, there's some liability involved because you're asking the roof material. And I guess the easiest way to talk about these flow control drains is that there's a little kind of dam there, and there's kind of weir holes in this dam, and you're able to kind of dial it in, and basically what you're doing is you're using the roof as a pond. Some roofs don't need that help, but on these roof control, these flow control devices, it actually lets the water pond up a couple of inches. And that was one of the things he's like, what, I don't have a good feeling about the roof material being able to sustain this kind of load over any period of time. And that might be something that it'd be interesting to talk to some roofing manufacturers and see what they have to say about, water retention on the roof, using that as a strategy. They might say, hey, whoa, no, you'd void the warranty if you used it like that. Also, you need to know and you need to calculate with the structural engineer because you're going to have that additional load on the roof. So, and also he pointed out you still need a secondary storm system, so you don't really get away with eliminating a set of pipes coming out of the building. On the green side, he pointed out, you have to have the right type of drain bodies. And also with LEED, you're not supposed to have any sort of permanent irrigation. And also, it's a very, very large target when you're going through the value engineering exercise. And it's very, something that, again, you're just looking at the benefits of it. A lot of people just drop that and say, what, it's really not that important. Yeah. But there again, productivity, could potentially trump that. I don't think they look at that too much, or as much as they should. And again, I've had some experience with green roofs a little bit, not so much in design. There's one design in particular that I was involved with, one project where I was involved with on the commissioning side, and it wasn't really a green roof. More or less, it was a lawn over kind of some rooms. So, but there's still, some issues. If you're going to put dirt over a structure, it's kind of like some buried classrooms is really what it boiled down to. But there's some tray systems. Typically, you're going to have these trays of a certain size, and they're going to interlock and fit together. You don't want them flying off during a wind event, but they're going to stand off, and that's where the drain bodies, picking the right drain bodies. You don't want those interfering with the type of green tray system that you're going to be using, and most of them are tray systems. It's not like they're planting a field on top of a roof. It's just they use these 4-inch deep tray systems or whatever the dimensions are, but roughly speaking, they may be like 4 to 6 inches, and they're very low maintenance plants, but they're not no maintenance plants, and that's where a lot of the extra maintenance and importance of the expense of maintaining and keeping that green roof over a long period of time. Then I'm like, okay. So that's the engineer's perspective. What about a manufacturer's rep? What do they say about this roof control, this flow control roof drains? Now, the local rep said, you know what? In the 26 years that I've been doing this, I might have sold him like 3 to 4 times. So it really was something that just is not used in these areas. And they have to be set right. The weirs have to match the load, the roof load, and that's something that's very important. And then he also mentioned siphonic roof drains, which again is something that I really haven't been exposed to, and which kind of the advantage of siphonic roof drain systems is that you actually have smaller piping, but it's still not very common. So I went from the manufacturer's rep to talk to the engineering department over at a manufacturer. So this is Chris over at J.R. Smith. Thank you very much for spending a lot of time to kind of, he's a wealth of knowledge. And that's, something that you have to keep in mind. You may get to the manufacturer's rep locally, and they might have limited knowledge. They might not, they might be able to help you out, and they might be great guys, but they might have a limitation on the knowledge that they can give you. So it's not uncommon for you to say, okay, you know what? Let's take another step. Let's take it another step up and go directly to the manufacturer. So the manufacturer is going to have an engineering department that's going to be able to support designers out there with more complicated questions. If you have a real detailed question that you need an answer to, you can contact the manufacturer directly, typically, and you can get some good information. And again, Chris was nice enough to go over some things with me. So typically, what he said about the flow control roof drains, you can reduce the pipe size a little bit, and typically the problem is that they've been around for a while. They've been around since probably the 60s or 70s, but only several there's cities, there's a very regional need for these. Again, because of the systems, because of the certain things that the stormwater management, stormwater people can actually handle, or whether it's combined sewer with storm. So several cities have mandated that flow control be used in some regards. It might not be very deep. They might have different requirements. This is where you're going to have to do your own homework. But it still requires, again, the secondary roof drainage system, so you don't get away with that. What he explained is that these are like, it's a cone inside a standard roof drain. And what this does is it allows you to set an overflow height and maximum buildup rates. So they can have different weir openings. So they have the same cone can be different weir settings. So typically one weir might handle 10 gallons, and so you're able to kind of dial that up to 3 or 4 weirs and a maximum height of 3 inches of retainage. And this is on a flat roof. If you're doing a slope roof, then you can get up to 6 inches. But again, the overflow has to be set at the maximum. So some of the areas that, where are they used? New York City uses a lot of these. Chicago, some cities in Wisconsin, it's more of a standard. But again, it's not everywhere. Obviously, most often you can use the retention tank, and you can use that with the reuse of that water. So I think, but I found it interesting. It's with setting the weir, and as a commissioning authority, setting this weir is one of those things where I'm like, does the contractor really know? I mean, what is it? Because your submittals really have to show the number of weir openings. So it can be changed in the field, obviously, with certain settings. Certain of the drain bodies can be changed and manipulated. Engineers also is ultimately responsible for checking the settings. And again, as a commissioning authority, that's something that I'd want to be up on too, to make sure that not only were they installed and set right, that you could actually make sure that the contractor is doing what they need to do, and that we don't have a collapse, a breach because it was set too high, or it's not actually fulfilling the requirements of code and it's set too low. So that was pretty much it on the flow control devices. Coincidentally, he said that there's a lot of backwater sewage valves that are used in systems like this. So again, in situations where you don't want that kind of coming back in your building, because an overflow is just, in a system, an overflow can be just about anywhere. And it can back up depending on where you're located in the system. Your building could end up being that overflow. And that is the last thing that you want in your basement is, overflow raw sewage. That is not going to be good. So a lot of backwater valves to make sure that, the waste is going out and it's not coming back in. All right, so we jump to siphonic roof drains. Siphonic roof drains, you can use, I guess you could use it as a flow control device, because you really can calculate the desired flow. These have been used, again, it's a newer technology. Well, I say new technology in the U.S. It's been around since about 2006. Europe has been using this since the 1970s. But really what you do is you have a system. And the siphonic system is, you can have a max drop of about 30 to 40 feet. So it's limited on how far you can drop with the system. Because you have the lower pressure, you have faster velocity, so you're going to have some impact and some system impact with that. So you want to be able to calculate the pressure drop and the flow rate on this. The thing about it is that a lot of the systems are calculated using software. Most manufacturers have these software, but it really is a trial and error because you have to kind of balance the system so no one section of the roof runs out of water before another, because then you lose kind of the siphon effect. It's really and the whole system is really geared for low-rise buildings with large roofs. But you can really have some substantial savings, 40 to 50%, on the piping. And again, this is one of the benefits is that with a siphon system, you don't have to slope the piping. So if you have situations where, piping slope may be an issue, maybe a siphonic system might be something that you'd really want to investigate a little bit more. So the drain has an air baffle, and the pipes are self-priming. So you use 100% of the pipe, and that's the whole goal. Is you not only have the pipe, but you have the pipe and it's self-priming. So it's really getting sucked with that lower pressure, getting sucked down, faster velocity, and it really does again reduce the size of the pipe. Things that you have to watch out for: the piping layout. Because you're using manufacturer software, the piping layout has to match the software design. Any change of the piping layout, and this has to be noted in the drawings, they really have to be brought back to the engineer to be recalculated to make sure it's okay. So that's it. You can actually use them for high-rise buildings, he was mentioning, but you really need to basically what you end up doing. And you can have a kind of a hybrid system. You could have a siphonic system for a certain amount of time or a certain drop, and then go into your standard system. That's okay. You just have to kind of vent, provide a vent at that connection point. So you can add basically air back into the system. All right. Well, I hope that was educational. I hope that you learned something. If you didn't know what blue roofs were, if you didn't know that there were flow control drains, roof drains, if you didn't know there were siphonic systems out there, maybe there's a couple of different things you can kind of do your own research and investigate. Some of the things over at J.R. Smith, they do have some videos that you can use and take a look at and see exactly how these different systems operate. So thanks so much for listening. If you know anybody who's looking for more information like this, consider passing this episode along. I really appreciate it. If you're not a subscriber, consider joining my growing community of people just like you over at HVAC360.com for some more weekly goodness. And lastly, I'd be greatly honored if you go over to Apple Podcasts and leave me a rating and review. If you also, I would say, go over to YouTube and subscribe there, even if you listen to the podcast normally just through your podcast app. So, all right, that's a wrap for this week and this episode of HVAC 360. I'm Matt Nelson, helping you be the best and the brightest in the field of HVAC. And as always, know what you build and share what you know.